Okay, the last video is going to be all about unit number 5. So this is when we talked about exponential and logarithm stuff. So we'll start right here with number 50. So anytime that you can get something into being the same base, that's what you want to do first. So in this case, I'm going to keep my 6 and I'm going to change my bigger one, that 36, into 6 squared. And now if two things have the same base or their bases are equal, then I know that their exponents are also equal. So I'm going to say that negative 2a is equal to 2, and so a is equal to negative 1. Okay, on number 51, I'm going to do the same thing. So I'd like to take this 6 and move it up to the top, and in order to do that, I'm going to change that into being 6 to the negative 1 power. So anytime you change sides of a fraction bar, you want to put a negative on your exponent. And so again, if my bases are equal, I can now say that my exponents are equal. And I'm going to add that 2 over to the other side. So negative 1 plus 2 gives me 1. Okay, on 52, I'm going to use that same trick, except that I need to combine some things first. So I know that if I'm multiplying something with the same base, I'm going to add their exponents. So I'm going to have 2r minus 1 plus r. And then over here, I'm going to keep my negative 3r minus 3. And then again, if two things have that same base, or my bases are equal, then my exponents are also equal. So I'm going to go ahead and make this one 3r. So I'm going to say that that means that 3r minus 1 is equal to negative 3r minus 3. And do a little math on this. So I'm going to add this over. That gives me 6r. And I'm going to add over my 1 here. So that's going to give me negative 2. And so I'm going to say that r is equal to negative 2 over 6, or negative 1/3. Oops, I forgot my negative on the 1/3 there. Negative 1/3. Okay, same thing's going to happen here, except that I need to start by making this 81 into a 9 squared. And we'll talk about that again in just a minute. And then I'm going to also make this 81 into a 9 squared. So before I can add these exponents together, I'm going to say that if I have an exponent raised to an exponent, I'm going to multiply those together. So this is going to give me negative 6b, and then I'm going to add to that the 2b for my exponent here, and this is still 9 squared over there. And now my bases are equal, so my exponents are equal, so that's going to give me that negative 4b is equal to 2. And so b is equal to negative 2 over 4, or negative 1/2. Okay, 54 and 55 are kind of a mess. I need to start by making these. I'm going to change these into bases of 6. So that's going to be 6 squared to the negative 2x. And 6 squared... erase that and put my squared inside with those parentheses. So one more time, 6 squared to the negative x plus 3, and then 216 is 6 cubed to the negative 3x. So again, kind of messy to get us started here on this one. So let's see here, that's going to give me 6 on this side, and this is going to give me negative 4x. I don't know if you can read this because it's kind of fuzzy and I'm running out of space, but negative 4x right there. And then with this one, I'm going to multiply in, so I'm going to have plus negative 2x plus 6. And then over here, I'm going to have 6 to the negative 9x power. Okay, so what all of that says is 6 to the negative 4x from multiplying those together. And then I'm going to add my exponents here, so plus, and then this would be negative 2x and plus 6, and then negative 9x over there. So I can't get my camera to focus any better. Okay, and again, if my bases are equal, then my exponents are equal. So I'm going to have negative 6x. I'm going to add these two together. Negative 4x plus negative 2x gives me negative 6x. Plus 6 is equal to negative 9x. And then I'm going to go ahead and add over my 6x this way. So that's going to give me 6 over here. and I'm going to add over my 6x gives me negative 3x over there. And so I'm going to get that x is equal to negative 2. Okay, and then the last one on 55, let me see if I can kind of partition that off a little bit. So on this one, I'm going to say that 125 is 5 cubed, so 5 cubed. I keep forgetting to write my exponent in there before I close my parentheses. So 5 cubed to the negative 2x times 5 squared to the negative x is equal to 5 squared. Right, and then I'm going to multiply these, so that's going to give me negative 6x, and then I'm going to add my exponents here, so that'll give me plus 2x is equal to 5 squared. And negative 6x plus 2x gives me negative 4x, so I'm going to have negative 4x is equal to 2, and so x is again equal to negative 1/2. You can't see the answer. Move that over just a little bit. Okay, when I get down here to numbers 56 through 60, I'm working with e's on these, and I'm working with things that I cannot make into the same base. So I can't change a number into a base of e. But remember that the opposite of an e is a natural log, so we're going to use that kind of a lot. What I'd like to do first is get this exponential by itself. So let me grab my calculator too here for just a second. And I'm going to get that by itself first. So I'm going to do that by dividing by the 2. So I'm going to say e to the b plus 5 power is equal to 31. Okay, let me move that 31 over just a little bit. I'm going to need a little bit of room on that. Because now I'm going to say that I know the inverse of an e is a natural log. Just like the inverse of a square root is a square, I'm going to take the natural log of both sides. And when I do that, I can use the logarithm property that says that this can come down to the front. Okay, so that's going to give me, to start off with, b plus 5 times the natural log of e is equal to the natural log of 31. Okay, and because they're inverses of each other, I can say my natural log and my e cancel out, leaving me just with 1. So b plus 5 is equal to the natural log of 31. And the natural log of 31 is just a number in my calculator. So I'm going to go find my natural log button. It's right here next to the 4, right below logarithm. So there's my natural log button right there. So in my calculator, I'm going to put in the natural log of 31. And then I'm going to subtract over my 5. So minus 5 gives me that b is equal to negative 1.566. It told me to go out to 4 decimal places. The 10,000th spot gives me 4 decimal places. Okay, let's do the same thing with number 57. So I'm going to start by getting my exponential by itself by dividing by 10. So that's going to give me 3.9 over here. And again, I'm going to take the natural log of both sides. So that'll bring my a minus 1 down to the front. So I'm going to end up with a minus 1 times the natural log of e, which is going to cancel out, is equal to the natural log of 3.9. Okay, so back in my calculator, I'm going to do the natural log of 3.9, and then I'm going to add over my 1. And that's going to give me that a is equal to 2.36. Let's go ahead and make that 1 0. Okay, 58, I'm going to get my exponential by itself. This time it doesn't divide in nicely, so I'm going to go ahead and leave this first as just 96 divided by 5, and I'll deal with that in my calculator here in just a few minutes. And again, take the natural log of both sides, bring that exponent down to the front, let my natural log and e cancel out. It's going to give me that x minus 7 is equal to the natural log of 96 divided by 5. If you want to use it, let me remind you that in your calculator, to enter that fraction, you can do alpha, f1, and number 1. It'll put that nice neat fraction in for you. You don't have to use it, but you can. Alright, so back in my calculator, I'm going to do the natural log of alpha, f1, number 1, and put in 96 over 5. And then to get x by itself, I'm going to add 7. So plus 7 gives me that x is equal to 9.95. Let's go ahead and make that 50. I guess we could make it 549 since it's just a 1 after that. There we go. Okay, I'm getting this one by itself right here is going to give me e to the n plus 8 power is equal to 87 over 6.6. And take the natural log of both sides. Bring this down to the front. Gives me that n plus 8 is going to be equal to the natural log of 87 over 6.6. Alright, this would be a really good place to use that alpha F1 number 1. Alright, so back in my calculator, I'm going to put in the natural log of alpha F1 number 1, 87 over 6.6. And then I'm going to subtract over my 8. And that one gives me that n equals negative 5.4212. Okay, and finally on number 60, this time I have a little bit of a different method to getting my e by itself. Here's e right here. So on this one I'm going to add over my 5, and that's going to give me 30, and then I'm going to take the natural log of both sides. So same method, just a little bit different method of getting that e by itself. So I'm going to say that negative 5x is equal to the natural log of 30. And so in my calculator, I'm going to do the natural log of 30, and then I'm going to divide by negative 5. And so that gives me that x equals negative 0.6802. Okay, on 61, I start getting into some logarithm questions. Let me remind you that anything that's in here with a logarithm needs to be positive. I can't take the logarithm of a negative value, so we'll need to check on that as we work through these. And also let me remind you that if I don't have a base on a logarithm, it's an implied base of 10. But on 61 and 62, what's going to happen is once I have one logarithm on this side and one logarithm on this side, if they are the same, my logs can cancel each other out. And so I can say now that negative 3r minus 2 is equal to negative 5r minus 10. So I can just take those logarithms out. Alright, I do want to check and make sure that I'm working with some positive values here. So I'm going to say that this has to be greater than 0 and that this has to be greater than 0. So let's see here, this is going to give me that negative 3r is greater than 2. And remember, when you take the, when you divide by a negative on an inequality, it's going to flip it around. So I'm going to need an r value that's less than negative 2/3. Or let's see what happens with this one. This is going to give me 10. And so that's going to be less than, and this is going to be negative 2. So I'm going to work with this one right here, because if r is less than negative 2, it's already going to be less than negative 2/3. Alright, so let's see what all we get here. I'm going to add over my 5r, that's going to give me 2r. And then I'm going to add over my 2, so that's going to give me negative 8. And so I'm going to get that r is equal to negative 4, which is less than negative 2. And so that's okay. That one can be my answer. So just be sure you check for those extraneous solutions on these. Okay. Same thing over here. My log of 15s can cancel each other out. There's one on each side. Let's check my domain issues here. So I want that to be greater than 0. And this to be greater than 0. So let's see, I'm going to say that x is greater than negative 5/2. And over here, x is greater than negative 2/3. And I'm going to go with this one, because if something is greater than negative 2/3, it is already greater than negative 5/2. So work with the bigger one there. Okay, so 2x plus 5 is going to be equal to 3x plus 2. And we could go either direction with this. I'm going to subtract my 2x over here so that I just get x over here on this side. And I'm going to subtract my 2 over here, which just gives me 3. And 3 is bigger than negative 2/3. That is not an extraneous solution. That's a good solution. Okay, turning over on the back to number 63. I've got a similar situation. I've just got some harder stuff to work with on the inside here. So let's see here. Let's start by saying 24 plus 3n has to be greater than 0. So n needs to be greater than negative 8. And over here I'm going to say, let's go ahead and take these, let's go ahead and take out that common factor of n on this one. So n has to be greater than 0, or n has to be greater than negative 5. So I'm going to work with my biggest one and say that my n values have to be greater than 0. Alright, let those cancel out. So that's going to give me that 24 plus 3n is equal to n squared plus 5n. And so let's see here, I've got n squared plus 2n minus 24. Move everything over onto one side together. And so let's see here, my factors of 24 that will subtract to give me 2 are going to be 6 and 4. So I'm going to have plus 6 and minus 4. So I've got that n is equal to negative 6 and n is equal to 4. But only the n equals 4 is going to be my answer, because we said that my values have to be greater than 0. So always go back and check on those domain issues. Okay, let's hear a similar question over here. Let me go ahead and take out the 4r. So r needs to be greater than 0 and r needs to be greater than 3 over there on that side. This side I'm going to have negative 35 plus 3r squared. Nothing I could take out of that side. So let's see here, 3r squared has to be greater than 35. So r squared needs to be greater than 35 divided by 3, which is like 11.667. And let's take the square root of that. So square root of that is going to be 3.41-ish. So the positive version of that is going to be my bigger one. So I need to make sure that my r values come out to be bigger than 3.41. So let's see here. I'm going to let my logarithms cancel out. 4r squared minus 12r is going to be equal to negative 35 plus 3r squared. So let's move over to this side this time. So r squared minus 12r plus 35 is equal to 0. So that's r and r. And let's see here. My factors of 35 that will add to give me 12 are going to be negative 7 and negative 5. So I'm going to get that r is equal to 7 and r is equal to 5. And both of those are bigger, so both of those are perfectly acceptable answers. And always be sure you check your domain just to make sure that they come out to be right. Alright, on 65, I only have a logarithm on one side. Let's start by getting it by itself. So I'm going to say that's the log base 5 of 6n is going to be equal to, and I'm going to divide this over, so negative 2. Anytime you're in a logarithm form and you feel kind of stuck, let's change it into an exponential. So I'm going to say that I have a base of 5, an exponent of negative 2, and that's going to be equal to 6n. Alright, so I can put all of that into my calculator. So in my calculator, I know that's going to be 1 over 25, but let's go ahead and put this in. So I'm going to have 5 to the negative 2 power, and then I'm going to divide by 6. And that's what that gives me. And I think they've still got us rounding to 4 decimal places on this one. So I'm going to say that n is equal to 0.0067. Okay, again, let's check and make sure. It did not give me a negative value. It did not, so we are good. All right, log base 8 of 3x is going to be equal to 27 divided by 9, so that's 3. So I've got 8 to the third power is equal to 3x. Okay, so again, let's let our calculator do a little work for us. So I'm going to do 8 to the third power and divide by 3. And that gives me that x equals 170.6667. Lots of sixes on that one. Okay, starting with 67, I need to do a little bit of work on it first. I need to get it down to where I just have the one single logarithm. So anytime I'm subtracting logarithms, I can condense that down to a single logarithm by dividing. So I'm going to have x squared minus 9 on the top divided by 7 is equal to 4. Okay, I'm in a logarithm form. I'm kind of stuck, so I'm going to change it to an exponential. So that will be 3 to the 4th power is equal to x squared minus 9 over 7. All right, so in my calculator, I'm going to do 3 to the 4th power and find out that's 81. And I'm going to go ahead and multiply over by the 7. So times 7 tells me that 567 is equal to x squared minus 9. So I'm going to add over my 9 and work with it this way. And I'm going to say that x squared is equal to 576. And I think the square root of 576 is 24, and it is, yeah. So x is going to be equal to 24. Normally, again, I would use the plus or minus version of that, but remember we can't plug in anything negative inside here to my logarithm, so we'll just use that positive 24. Okay, same thing on 68. I'm going to condense by dividing, so that'll start off as 2x divided by 8. And I'm going to change into exponential. So I have a base of 3, an exponent of 2, and I'm going to go ahead and change this into being x over 4. All right, so 3 squared gives me 9, times 4 gives me 36, so I get that x is equal to 36. Oops, sorry, you can't see. Okay, natural logs work the same way. This time, though, we are adding in between them. I can condense to a single log, adding by multiplying things together. So that's going to give me negative 6 is equal to 3. And I could go ahead and also say that a natural log is the same thing as a log with a base of e. Let me go ahead and change that into a log with a base of e. So that's going to be e to the third power is equal to negative 6x. And e is also a button in our calculator. It's going to be right here above the natural log, right there. So I'm going to do second e to the third power. And then I'm going to divide that by negative 6. All right, that does give me a negative right there, but notice if I plug in right there, the negative times the negative would give me back the positive that I'm taking a logarithm of, so I'm okay. So x is going to be negative 3.3476. Okay, same thing on number 70. I'm going to put those together using multiplication. So that'll be 3 times x plus 7 is equal to 3. Let's change this into a log with a base of e. So that's going to be e to the third power is equal to, and I'm going to go ahead and multiply these together, so 3x plus 21. Okay, in my calculator, I'm going to do second e to the third power. And I'm going to subtract over my 21 and divide by my 3. And I get that x is equal to negative 0.3048. Okay, last piece here with my exponentials. I'm going to start with my exponentials making a table. So I'm going to make a table of some values here. And I'm going to start off with x values of negative 1, 0, and 1. It gives me nice values when I work with that. And let me start with my base of just 3x for a second. So that's going to give me 3 to the negative 1 power gives me 1/3. And 3 to the 0 power gives me 1. And 3 to the first power gives me 3. Now I am working with some transformations here, so what I'm going to do is I'm going to go ahead and multiply this by 2. So I'm going to do my 2 times my 3 to the x gives me 2/3, 2, and 6. And so I'm going to take these points, -1 2/3, and 0 2, and 1 6, and I'm going to also move them. You can't see my points. There's my points right there. And I'm going to also move them. This is inside my function right here, so opposite direction from what I would think. So that's going to be to the right 1. And this one over here is going to be on the outside, so I'm going to move down 2. All right, so with an exponential, we usually have a horizontal asymptote on the x-axis. So I'm going to take that and move it down 2, and it's going to be right here on the edge of the graph that they've given me. I guess that's why they gave it to me that way. And I'm going to go to -1 2/3, and I'm going to move to the right 1 and down 2. And then I'm going to go to 0 2, and I'm going to move to the right 1 and down 2. And I'm going to go to 1 6, and I'm going to move to the right 1 and down 2. And so that gave me a vertical stretch, and my right 1 and down 2. Okay, our last question works with a base of 10. So with my exponential, my table would be like this. But with my logarithm, it's going to be a switching of x and y, or an inverse. So for my logarithm table, I'm going to use 1/10, 0, and 10. Oops, I didn't switch my x and my y on that one, did I? 1/10, 1, and 10, like that. Okay, so find your exponential table, and then use the inverse, so the switching of x and y. And these are the points that I'm going to graph with a move to the right 2, because that's on the inside. So right 2 and down 3. Okay, a logarithm graph usually has an asymptote on the y-axis, so I'm going to move that over to the right 2. So that's going to be here. And I'm going to take each of my points and move right 2 and down 3. So I'm going to go to 1/10, -1, and I'm going to move to the right 2 and down 1, 2, 3. And I'm going to go 1 0 and move to the right 2 and down 1, 2, 3. And I'm going to go to 10. We're out of space here. 10, 1, and I'm going to move to the right 2 and down 1, 2, 3. And follow my asymptotes, just like that.